Good morning, everyone. This is Dr. J. Deepa, Assistant Professor from Food Technology Department, Hindustan College of Engineering and Technology, Coimbatore. So, in this video, we are going to see about the size reduction machineries. So, when we see about size reduction, it is nothing but reducing the size of the particles. So, traditionally, we use stones. So, that is, two circular stones were used to reduce the size of the particles. So that will be rotated manually, either using hands or animals or with the help of humans in olden days, where this one stone is stationary and another one is moving. So in the upper stone, we have a hole where the material will be fed inside the gap between the stones, and it will be crushed and we'll be getting the product at the edges of the lower stone. So this picture, it shows the traditional method of reducing the size of the particle, that is using two stones. So that is time taking. When we go traditionally, that size reduction process will be time taking. So that to reduce the time consumption, size reduction equipments have been developed. So that is broadly classified under two categories: crushers and grinders. Crushers will produce a coarse particles, where we have jaw crushers, gyratory crushers, and crushing rolls. And in grinders, that is used to produce very fine particles, where we have hammer mill, rolling mill, attrition mill, and tumbling mills. So crushers, they do heavy work, that is very hard materials will be broken down into small pieces. In crushers, we have two types: primary crushers and secondary crusher. Primary crusher, where it is reduced to 150 to 250 lumps, and in secondary crusher, further size reduction will be taking place, where it is reduced to 6 in size. Uh, Coming to the jar crusher. So jar crusher, here we have two heavy jars. One is fixed and another one will be moving. So this is a reciprocating type mechanism. So here it will be the movable jar will be moving front and back. In this picture, you can see the food material will be fed at the top, and when it is coming down, it will be crushed between the two jars and will be collecting the product at the bottom. Here it will be around 250 to 400 strokes per minute. The jars will be rotating, and here it is kept at an angle of 20 to 30 degrees. So here this is the commercially available jar crusher. Next is the gyratory crusher. So here this gyratory crusher, it consists of a truncated conical casing, and then inside which a crushing head rotates. So this is the crushing head that rotates front and back, and then we have, this is the casing, conical casing. Here the material will be fed at the top, and then it will be crushed between the gap between the cone and the casing. And then here we have 125 to 425 gyrations per minute, and the product will be crushed here. So next is the crushing rolls. So here by compressive action, the size reduction will be taking place. Here we have two cylindrical rollers, where the material will be fed between the two rollers, and the two rollers will be either rotating in the same direction or in the opposite directions. When it passes between the gap between the rollers, compression will be taking place. So the material will get reduced in size, and at the bottom will be collecting the material. So in the crushing rolls, we have two types based on the surface. One is smooth roll crusher and another one is serrated or tooth roll crusher. Smooth roll crusher, the surface of the rollers will be smooth. So in this, due to compression, the size reduction will be taking place. And in serrated or tooth roller crusher, due to compression or impact, the size reduction will be taking place. Serrations mean tooth-like projections will be on the surface of the rollers. So apart from that, we have single roll crushers and double roll crushers. And also this picture shows the smooth roll crusher, and this one is the toothed roll or serrated roll crushers. Next is the grinders. So these grinders were generally used to produce very fine powders. So here if we see the particle size of these powders, it will be around 36 microns. And then here roller mills or hammer mills or attrition mills were used to reduce the size of the particles. So here hammer mill. So due to impact, the hammer mill will be reducing the size of the particle. So it contains a high speed rotor running inside a cylindrical casing. So this is a cylindrical casing. Here we have rotors, and the hammer's heads were attached to these rotors, and this rotor will be driven by the motor. So it will be rotating. So the material will be fed at the top, and between the gap between the casing, cylindrical casing, and the rotor head, the material gets compressed. And at the bottom, you can see the seats will be kept there. So when the particle reaches the particular size, then it will be collected at the bottom. So here it will be rotating at 1500 to 4000 rpm. So this animation shows the working of a hammer mill. Next is the burr mill. It is also known as plate mill, disc mill. So based on the material it is used, it is known as stone mill, burr mill, plate mill, or disc mill. When we are going for stones, it will be, when we are going for disc, it will be around 20 to 137 centimeter in dia, and it have operated at the capacity of 350 tonners. So here also one disc or one plate will be rotating and other will be stationary. So here this picture shows the burr mill. So burr stone, this is an abrasive stone that is used by to reduce the size of the particle. So here due to compression and shearing, the size of the materials will be reduced. So overall we have seen about the size reduction equipments. Thank you.